After studying this module, you shall be able to know what is fiber, how the source of the fiber can be identified, what is the importance of fiber examination, and what are the instrumental techniques used for fiber analysis. Let us start with the introduction of fiber. Fiber is a rope or a string used as a component of the composite material. It has a highly individualistic character because of its chemical composition, manufacturing process, dimensions, dyes that are examined with the help of TLC FTIR analysis, optical properties, impurities from the manufacturer, wearer, partial melting, paint smears or other stain, changes in the material due to aging. The fiber evidence can help innocent suspects, such as in case of a burglary where the suspect denied entering the house, where costly items like jewelry were stolen from a carpeted room. The shoes of the suspect was smeared with mud and it carried about 50 different types of fibers. However, none of them corresponded to that of the fibers found in the carpet. The mud on the shoes that corresponded with the mud from the club ground corroborated his alibi that he was in a particular club at the time of burglary. Fibers are generally of two types, that is the natural and the synthetic fibers. So, first we will study about the natural fibers. Natural fibers are found in a raw state in plant and animal fiber. Natural fibers include hemp, bamboo, cotton, wool, silk and fibers of polylactic, I repeat, and fibers of polylactic acid or the PLA and polyglutamic acid or the PGA polymers made from renewable sources such as corn. Most of the natural fibers such as hemp, bamboo, cotton and wool are spun from short fibers into a sliver and made into roving and then spun or entwined to form a continuous long fiber that may be woven, braided or knitted into a fabric. The resulting fabric usually has a fluffy appearance unless finished, serged or otherwise treated, that results from the short stable fibers from which they were produced. Silk is a naturally spun long polymer that is very similar to the man-made fibers. The resulting fabrics are shiny, smooth and are soft to touch. PLA and PGA are the natural fibers that are polymerized by an industrial process. The fibers can be easily identified and compared by the microscopic inspection itself. Next comes the synthetic fibers. The synthetic fibers are formed due to the extensive research done by scientists so as to improve the quality of the animal and the plant fibers that comes under the category of natural fibers. Usually the synthetic fibers are formed by forcing through the spinnerets into the air by the process of extrusion, thereby resulting in the formation of threads. Earlier, artificially manufactured fibers were obtained from the plant cellulose and hence were known as cellulosic fibers, whereas the synthetic fibers are obtained from the small molecules or the synthesized polymers. The compounds that are used in the making of the synthetic fibers are obtained from the raw materials such as in the petrochemical industries or the petroleum based chemicals. These materials are polymerized from long linear chains having the chemical bonds between two adjacent carbon atoms. different chemical compounds will be used to produce different types of fibers. The man-made fibers are produced by combining polymers or small molecules. An example of the raw material is the petroleum-based chemicals. Synthetic fibers account for about half of all the fiber usage, with applications in every field of fiber and textile technology. Although many classes of fiber based on the synthetic polymers have been evaluated as potentially valuable commercial products, four of them are nylene and the polyolefin dominate the market. Here polyester accounts for about 60% of the total volume of the synthetic fiber production, with all four of them accounting up to 98%. The commonly used synthetic fibers include nylon in the year 1931, Moda acrylic in the year 1949, olefin in the year 1949, acrylic in the year 1950, polyester in the year 1953, carbon fibers in the year 1958. There are also different types of fibers like the glass fiber, viscose, cupra, ammonium, rayon, aramides, etc. Polymers are defined as the substances that are made up of chains of monomers linked together to form a large molecule that may be thousands of nanometers long or the monomers long. Polymers are defined as the substances that are made up of chains of monomers linked together to form larger molecules that may be thousands of monomers long. Nylon and polyester are the synthetic fibers. Now we will study about the source determination of fibers. Cloth fibers are exchanged between persons and objects and between objects themselves, and that's why can be readily associated with a specific source such as fabric from the victim, suspect and from the scene. The transference and the detection of the fiber depends on the nature and also on the duration of the contact between the victim, suspect or both, and the persistence of the fiber after they have been transferred or exchanged. Cotton fibers are the most commonly used plant fibers in the textile production. The type of fiber, its length and the degree of twist also adds to the diversity found in cotton fibers. The value of the cotton fiber identification is also influenced by the various processing techniques, for example the mercerization, and also by the technique of color application. The presence of other less common plant fibers at the crime scene or on the clothing of a victim or suspect increases its significance. Wool is the most common animal fiber that is used in the textile production and is obtained from the sheep. The coarseness of the wool fibers often dictates the end use of wool. The finer woolen fibers are used in the making of woolen clothes, whereas the coarser fibers are included in carpets. The woolen fibers may also include camel, alpaca, cashmere and mohair. Fibers found at the scene of crime have increased significance because of its identification property and can be easily linked to the victim, suspect or both. The most commonly encountered manufactured fibers are the polyester and nylon. The cross-sectional shape of the fiber, its end use, the amount of production and various other microscopic properties helps to increase the degree of rarity it has and that of the particular type of fiber. Next, we will study about the fiber examination and its forensic importance. Fiber has an important evidentiary value in the field of forensic science. It provides the variety of the clue materials such as the individual fibers, threads, a piece of cloth, a clothing, a cord string, ropes or their pieces, hair from different sources, woolen fibers, furs, etc. It consists of determining if a questioned fiber exhibits the same chemical, microscopic and the optical properties to that of the known source as of the fiber. A comparison requires an examiner to complete at least two of the analytical techniques for the characteristics like generic class, physical characteristics and color. Physical properties like density, refractive index, melting or softening point and the tensile strength gives important information about the fiber. The cross-sectional study of fibers reveal structural features that are otherwise very difficult to comprehend. The optical properties that are useful for the fiber identification are the refractive index, birefringence, the fiber elongation. The fluorescence is also very important property for the examination purpose. The examination is done by observing the presence or the absence of the fluorescence, color and its intensity of the fluorescence and the exiting wavelength. There are various techniques, processes and determination are made for the examination of the fibers. In forensic science, fibers as trace evidence are used to create a link between a crime and the suspect. A fiber can be defined as the smallest unit of the textile material having length many times greater than that of its diameter. A fabric is defined as the knitted or the woven form of fibers. The transference and the significance of the fiber association is affected by the type of fabric construction, spinning method employed, the type and the length of the fiber. These properties serve as an important clue during the commission of the crime by showing the possibility of the fiber transference between a victim and the suspect. Matching and comparison of the exceptional fibers are very useful in cases of investigation wherein certain fibers have been transferred between suspect and the victim. However, matching of common fibers such as blue denim or white cotton proves to be of less importance. The likelihood that two individuals had physical contact can be dramatically proven if cross transfers and multiple transfer of fibers are discovered between the clothing of suspect and that of the victim. Next, the textile fibers as evidence. This evidence is found in the cases of crimes against property like burglary, larceny, torn fabric or the loose fibers at the point of entry, fabric marks from gloves and fibers from the scene transferred to that of the suspect. This evidence is also found in crimes against person, like it indicates the force in crimes against person in rips and tears. Sabotage, that is the cut or tied parachute lines. In homicide, assaults, sex crimes, which is used to indicate contact by transfer of fibers between the victim and the suspect, clothing, transfer of the fibers between victim or the suspect at the crime scene. Then comes the preliminary examination. The fibers are examined visually with the hand magnifier and stereo microscope. This study indicates the twist of the thread, string, rope or cord and the number of strands, the number of thread in the string, number of fibers in each string. Then comes the testing of fiber. First here is the burn test. Look at a fiber, how it burns, its odor and appearance of ash. Then thermal decomposition, how a fiber breaks down when heated. Chemical test, test the solubility and decomposition of a fabric using strong acids such as hydrochloric acid or sulfuric acid or strong bases such as NaOCl, acetone, NaOH. This determines the fabric's polymers. Then comes the density. Density of water is 1 gram per milliliter. Olefin is the only fabric that will float in water. Next is the refractive index, bending of light as it passes into the air into a solid or liquid. Investigators measure the refractive index of an unknown sample with liquids of a known refractive index. Place the sample in different liquids until Beck line is no longer visible. Next comes the fluorescence. Some fibers will fluoresce when exposed to UV light. Laundry soap and some bleach agents have whitening agents that cause blue light to be reflected, making it appear whiter. Dyes, investigators use a fabric to see if it accepts a particular dye so as to identify and compare it to the unknown sample. Then we will study about the microscopic and the instrumental analysis. First, under microscopic and instrumental analysis is the scanning electron microscope or the SEM. The microscopic examination is useful to find out the structure, nature, diameter, presence or the absence of contamination, color and the cross-sectional structure. Scanning electron microscopy or SEM is a method of photography which requires instruments called the scanning microscope, which uses electrons rather than light to form an image. There are many advantages of using the SEM instead of a light microscope. Using SEM requires a large depth of field which allows a large area of the sample to be in focus at one time. A scanning electron microscope converts the emitted electrons into a photographic image for display. This affords high resolution and depth of focus. Next is the atomic force microscopy. Atomic force microscopy is a method which is carried out by using an atomic force microscope, which is an instrument that can analyze and characterize the sample at the microscopic level. The instrument allows the analyst to look at surface characteristics with very accurate resolution ranging from 100 millimeters to less than 1 millimeter. Next, we will study about the infrared spectroscopy. The infrared absorption traces of substance are individualistic in nature. If the patterns of absorption of the infrared rays of the crime scene sample correspond with the standard sample, then the common source may be identified. The IR or the infrared spectroscopy is defined as the spectroscopic technique that deals with the IR or the infrared region of the electromagnetic spectrum, that is light having lower frequency and longer wavelength as compared to the visible light. This spectroscopic technique covers a range of other techniques generally based on the absorption phenomena. IR spectroscopy can be employed to study and identify chemicals as will all other spectroscopic techniques. In this technique, an infrared spectrometer is used to produce an IR spectrum and samples in solid, liquid or gaseous state can be examined for. A graphical representation denotes the basic infrared spectrum wherein light abundance is plotted on the vertical axis and wavelength or frequency is plotted on the horizontal axis. The unit of frequency used in IR spectra is centimeter inverse. The unit of wavelength in an IR spectrum is usually given by microns, abbreviated as micrometer. FTIR or the Fourier transform infrared spectroscopy uses this technique. The IR region of the electromagnetic spectrum is generally divided into three regions: the near infrared, the mid infrared and the far infrared region, so called because of their relation to the visible spectrum. The higher energy near IR, approximately 14,000 to 4,000 centimeter inverse, can excite overtone or harmonic vibrations. The mid infrared, approximately 4,000 to 400 centimeter inverse, may be used to study the fundamental vibrations and associated rotational vibration structure. The far infrared, approximately 400 to 10 centimeter inverse, lying adjacent to the microwave region has low energy and may be used for rotational spectroscopy. The names and classification of these subregions are conventions and are only loosely based on the relative molecular or the electromagnetic properties. Next comes the pyrolysis gas chromatography or the PGC technique. This is a technique in which the synthetic fibers are pyrolyzed under controlled conditions. The fiber gives degradation products which are characteristics of the material. The chromatograms of the crime scene sample and the specimen on comparison may indicate the common source. This is a chromatographic technique in which the solid sample is directly converted into a gaseous form. Next is the TLC or the thin layer chromatography. Thin layer chromatography is the technique for the identification and comparison of the dyes on the fibers. It is highly sensitive, specific, rapid and a simple technique. It does not involve costly equipment and it can be used in all the laboratories. It is being extensively employed for the purpose of all over the world. TLC has a limitation that it cannot be done for the yellow colored fiber and also for small lengths of fiber. Using mostly our vision and some measurements of distance on the stationary phase, it separates the mixtures into individual parts. Samples are placed on the material that carries the various components in the ink different distances based on their different polarities. Next is the FTIR or the Fourier transform infrared spectroscopy. It is based on the absorption and wavelength of light in a fabric polymer and it can be used in a single fiber. It is a non-destructive in nature. The FTIR or the Fourier transform infrared spectroscopy is defined as a technique that is employed to obtain an IR spectrum of emission, absorption, photoconductivity or Raman scattering of solid, liquid or the gaseous samples. The spectrometer in a FTIR at the same time collects the spectral data over a wide range of. This property has an added advantage over the dispersive spectrometer because it measures the intensity over narrow wavelength range at a specific time. Today, the dispersive infrared spectrometers have become obsolete and have taken over by FTIR, thereby opening up new applications of spectroscopy. To convert the raw data into an actual spectrum, Fourier transformation is needed and hence the name Fourier transform infrared spectroscopy. However, this technique is a less spontaneous method to obtain the same information. Rather than shining a monochromatic beam of light at the sample, this technique shines a beam containing many frequencies of light at once and measures how much of that beam is being absorbed by the sample. Next, the beam is modified so as to contain a different combination of the frequencies, giving a second data point. This process is repeated many times. Afterwards, a computer takes all of these data and works backwards to infer what the absorption is at each wavelength. Next, under the instrumental technique is the PGS-MS. This technique burns and separates each combustion product of the sample, match results of chromatogram and products to be known. It can be used in short length of fibers but is destructive in nature. MS or the mass spectrometry is defined as the analytical technique that helps in the identification of the type and amount of the chemical present in a sample by measuring its mass to charge ratio, that is the M/E ratio, and the abundance of the gas phase ions. The plot of a mass spectrum is given by the ion signal as a function of its mass to charge ratio. The obtained spectra are used to determine the mass of particles and of molecules, their chemical structures and the elemental or the isotropic signature of the sample. In mass spectrometry, the chemical compounds are ionized so as to generate the charged particles or the charged molecules or molecular fragments by measuring their mass to charge ratio. In this technique, samples which can either be in solid, liquid or gaseous form is ionized by bombarding it with electrons that further results in the breaking of the sample molecules into the charged fragments. The resultant ions are then separated in accordance with the mass to charge ratio, usually by accelerating and subjecting them to magnetic or electric field of the same m/e ratio that will undergo the same amount of deflection. The ions are detected by a mechanism capable of detecting the charged particles such as an electron multiplier. Results are displayed as spectra of the relative abundance of the detected ions as a function of the m/e ratio or mass to charge ratio. The atoms or molecules in the sample can be identified by correlating known masses to the identified masses or through a characteristic fragmentation pattern. Now I will summarize all that we have studied in this module. Fiber is a rope or a string used as a component of the composite material. It has a highly individualistic character. Fibers are generally of two types, that is the natural and the synthetic fibers. Silk is a naturally spun long polymer that is very similar to man-made fibers. The resulting fabrics are shiny, smooth and have a softer touch. PLA and PGA are natural fibers that are polymerized by an industrial process. Earlier, artificially manufactured fibers were obtained from the plant cellulose and hence were known as the cellulosic fibers, whereas synthetic fibers are obtained from the small molecules or the synthesized polymers. Fiber has an important evidentiary clue in the field of forensic science. It provides the variety of clue materials such as individual fibers, threads, a piece of clothing or a cord string, rope or their piece, hairs from different sources, woolens, furs, etc. The examination is done by observing the presence of or absence of fluorescence, color and intensity of the fluorescence and the exiting wavelength. There are various techniques, processes and the determination is made for the examination of fibers.